sketch it. So what does this one do? It's first of all, it goes out, right? And it goes up. Well, it goes, no, it doesn't go exponentially. 11, 12, 13, it goes actually, what shape does this probably look like? Okay, let's just continue the trend here. What do we, careful. That point right there, if this trend continues right here, what's that middle point height going to be?
The lowest point.
What's it going to be? It's going to be 10. Yeah, it's going to be the lowest point, 10. If that trend continues, look.
Oh, wow.
19, 18, 17, 16, 15, 14, 13, 12, 11, 10, right? But are those contour lines, are they the same distance from each other?
No.
Yes, they are. Yes, they are. Look, they're concentric circles evenly spaced, right? So if you were to actually draw this, let me see how well I can do this. Let me see the perspective here. Does that thing start at the origin? No, it does not. What shape? Give me the word for this shape. You know it. Cone, right? So this thing is going to go up like this in 3 dimensions, right? Did the screen just go off? There we go. That's really not helping you, is it? Hold on a second. So this cone right here extends. Does everybody see the cone I'm trying to draw? Like that? Okay. So that's what it looks like. So we have Z going up. We have, what axis is coming straight at us? X and Y. Great. Okay, that's just what it looks like, right? So they want to know at each of these points what's the sign of like partial with respect to X and partial with respect to Y. So when you do let's just do one of them. Which one do you want to do? 10, 11, 12, or yeah, I know the numbers don't correspond to the ones you have. The numbers are off a little bit. Do you want to do Q? Yeah, so the numbers don't. So let's do QX right here. Let's look at QX. So Q is right here, yay. So what does QX mean? What's changing? X is changing or Y is changing? X is changing, right? So what stays the same? The Y stays the same. Y stays the same. So we're looking at, if we had a tangent line like this, we fixed Y, right? We fixed Y. As X increases, what happens to the Z value? It increases. So this is going to be what? This is going to be positive, right? What about QY? What's changing there? So that's the purple. I'll color this the right way. So this is the purple. Let's say I used, I don't know, green here. Now we go like this, right? So if we're going in the positive, if we're going out, effectively, positive Y direction, and this is a cone, if it helps you can look at this instead. What does it look like is going on if we do the positive Y direction? Yeah, you have to be very careful about this because by how this is labeled, which way, you have to assume or you have to label for yourself, which way is the positive Y direction? This way, right? We kind of assume that this is the positive Y direction and this is the positive X direction. Your tendency might be to think, oh, you're going away, so maybe look at it going this way. If you look at it going this way, it would be positive, right? But if you look at it going this way, what is it going to be? Negative. Does that make sense, everybody, on that picture? That kind of makes sense? Okay. So the green one right here. So what I'll put in little red marks here. We're looking at this direction and this direction. So this is going to be negative, like that. Case, they give you those two traces, which is kind of nice. So in this case, since it's fx, what's being fixed? Y is fixed, right? So in which path is y fixed? It's this one right here, right? This is where y is fixed. This is where y is fixed. So that's where y is fixed. So what's happening there what's happening there as x gets bigger? So x gets bigger in this direction. What is the sign of that one going to be then?
Oh, negative.
It's negative, right? Because it's going down, yeah. So what about now for the sign of fy? I'll switch to something that you can see. It's not, well, blue, great. We're looking at this curve right here. Putting blue on blue here. That's this one. So this is x fixed. So in that case, we're going in, where y is increasing, going in that direction. Is that uphill or downhill? Uphill, so you're going, it's greater than 0. Does that make sense? So you have to look at where, if x increases, so on the first one, what's going on at this point as x increases? As x increases, it's going downhill. You fix it. And what's happening as y increases here? It's going uphill. Kind of make sense a little bit? Okay, good. I'll use and do the same thing and use the limit definition, which is important that you realize still applies here. But in terms of finding partial derivatives, can you do them algebraically? Yes, you absolutely can do them algebraically. The key thing to realize is this. You ready, everybody? there are going to be a lot of variables thrown at you. When you take a partial derivative, only one of them, when you're taking the partial derivative, will be considered in motion. What I mean by that is fx, so in this case the partial of f with respect to x is changing. So what does that mean about any other variables that are present in the equation? They are not changing, they are fixed, right? So in this case, if we're doing fx, so f partial x, f, the partial of f with respect to x, what's fixed? Y is fixed, right? So in this case, when you are computing fx32, let's first find out fx of xy. That's the partial of the function with respect to x. So what do we treat as a constant? Y. If this is just a constant, if it helps you, call it a, whatever you want to call it. Maybe not change it because you'll get confused. But if we treat y as a constant and only x is changing, can you tell me what the derivative is going to be, fx, xy? The partial of f with respect? Nope, there's no quotient rule needed because there's only one variable. So what is it going to be at? 2 what? 2x over y plus 1. You just take, this is a constant. For the purpose of this, y is a what? Say it with me. Y is a constant. Y is a constant. Y is a constant. Y is a constant in this case when we are doing this one. So now, if we want to find fx at 3, 2, what does it equal? 2 times 3 over 2 plus 1, which is 6 over 3 is 2. And we solved that yesterday. Did it take us a lot longer yesterday? But did we get 2? You might remember we did get 2, right? So that right there is fx, the partial of f with respect to x. What could we also find if we wanted to? Fy of xy. We need to find a different partial. So what do we fix in this case? X is fixed, right? X is fixed. So if that's a constant on top, so you treat x squared as a constant, anybody want to tell me what the derivative is going to be? Negative x squared? Okay, so yeah, you think of it this way. You have a constant over y plus 1, right? What's the derivative there? Ah, there we go. Yeah, so what is it? There's still x squared, right? So it's x squared, absolute value of? Yeah, exactly. Because if you were to take the derivative of, so if you take the derivative of this right here, what's the derivative of, no, kids, you're going in the wrong direction. You're taking the derivative. So Ali is right. I'm sorry. I wasn't listening. Yeah, the reason that, yeah, you're doing one, hold on. You're doing one step of simplification, putting the negative in front, so it was hard to follow. I totally understand what you're saying now. So you're doing negative x squared times what? Y plus 1 to the what? Negative 2. Because you have effectively, you're doing the derivative of c times y plus 1 to the negative 1. But in this case, instead of c, I'm putting c there instead of what? X squared. Sorry. Thank you very much, Ellie, for cleaning us up on that one. So now, fy 3, 2, what's that going to be? Negative 9, 2 to the, so it's going to be negative 9 over, did I just not do basic math right there? 3, sorry, over what? It's going to be negative 9 over 9, which is negative 1. Remember we did that question yesterday, and like 3 different people came up with 3 different answers, but negative 1 was, remember that? Negative 1 was definitely the answer to this. The key here, everybody, I just have to tell you here, if you want to fixate on one part that I think is the most important linchpin item, remind yourself what is fixed. If you want to fix it, what's fixed, what's not moving. It's really, really hard to do because when you see x's and y's, you always think of them as all the time. And in this case, are they going to be variables all the time? No, they're not. No, they're not. So this is what I'd like you to do right now. I'm going to give you 3 different functions right here. First one, fx means what's changing x. So x is the variable. So what's fixed? Y. So when you do the derivative, what does it come out to be? 3. Yay. And if you do the other way, what does it come out to be? 2y. Bingo. Nice. So what about b here? If we did zx, xy, so x is treated as a variable. You drop the 5 to the front still, right? 5 times 3xy plus 2x, but then what do you have to multiply by? And it comes to the 4th power. You have to do the derivative of the inside, but with respect to x, right? So what's it going to be? Plus 2. Yeah, correct. So what about zy, xy? You drop the 5 first. Same idea, right? 3xy plus 2x to the 4th, right? But in this case, what is the coefficient? Just 3x. Because what if x is a constant, what's the derivative of 2x with respect to what? 0.
I think it's 3y plus
3 what?
3y plus 2. 3y.
Oh, sorry. Yes. Thank you. Thank you. It is 3y. Yeah. Yeah, it is 3y. You're absolutely right. It's the coefficient of the x. Yes. So let's do gx, xy. What do you have to use in this one? What do you have? What's the overall rule we use? What differentiation rules they play first? The product rule is the dictator one, right? Is the one that's, so it's going to be the derivative of the first with respect to x. What's the derivative of the first with respect to x? X plus 3y, right? Right? Times sine of xy plus the first times the derivative of this one, right? It's going to be y cosine xy. Yeah, very good. So gy of xy, same idea, right? But what do you drop down? You do the derivative of the first. What goes out front?
3.
The 3, right? 3e to the x plus 3y times sine of xy. That's the derivative of the first times the second plus the first, e to the x plus 3y times x cosine xy. Yeah. Wow. You just have to be really careful. It is super important that you are careful now because this is not as iterative as it will get. What I'm trying to say is that in single variable calculus land, when we started talking, when you did derivatives, you did first derivatives, but you also did? Yeah. So we're going to do all sorts of fun things. First and second derivatives. How many are there going to be? There's going to be a bunch. Do you have to be real careful about the order? Oh, yeah. Did Michael just go, I think he did. When we start having lots of variables, do your best to keep them in alphabetical order. That's fine. I'm saying you did it right. Just you're going to have the opportunity to reorder things sometimes. Just try to keep it in as alphabetic as an order as you possibly can without hurting